Imagine this. NASA and SpaceX are teaming up to send a spacecraft that can do something no other cargo ship has done before. Boost the orbit of the International Space Station, ISS. This groundbreaking mission, scheduled to launch in the early hours of Sunday, August 24th, is set to redefine how we maintain the space station's position in low Earth orbit. The Dragon spacecraft, which will lift off from Cape Canaveral Space Force Station atop a Falcon 9 rocket, comes equipped with a brand new propulsion system. This system, housed in the unpressurized trunk of the Dragon, includes an independent propellant setup and 2 Draco engines. These additions will enable the spacecraft to perform orbital boosts, a task traditionally handled by Russian Progress vehicles and the station's own thrusters. Bill Spech, the Operations Integration Manager for NASA's International Space Station program, explained during a pre-launch teleconference, the hardware located inside the trunk of Dragon contains an independent propellant system, separate from the spacecraft, to fuel 2 Draco engines using existing hardware and propellant systems. These orbital boosts will start in September and continue periodically throughout the fall of 2025, helping to keep the ISS in its desired orbit. This move is part of NASA's broader strategy to prepare for the eventual decommissioning of the ISS in low Earth orbit. But here's where it gets interesting. The Dragon spacecraft will remain docked to the ISS for about 5 months, making it SpaceX's first long-duration CRS mission. This extended stay will allow the spacecraft to perform the majority of the orbit-raising maneuvers, significantly reducing the workload on other vehicles. The launch window opens at 2:45 a.m. Eastern Daylight, or 06:45 UTC on Sunday, and the 45th Weather Squadron forecasts a 70% chance of favorable weather conditions. The primary concerns are cumulus clouds and lightning near the launch pad. The booster recovery weather is expected to be at a moderate risk level, with a slight chance of isolated offshore thunderstorms persisting into the early morning hours. The Falcon 9 first stage booster, designated B-1090, will be making its 7th flight. After liftoff, it will aim for a landing on the SpaceX drone ship, a shortfall of gravitas in the Atlantic Ocean. If successful, this will mark the 121st landing on this vessel, and the 492nd booster landing overall. The Dragon capsule, serial number C211, is no stranger to space, having flown twice before on CRS-26 and CRS-29 missions. This time, it will carry over 5,000 pounds of science and supplies, including 2,405 pounds of crew supplies like food and clothing. Notably, the mission will deliver 14 dedicated tortilla bags, each containing a total of over 1,500 tortillas, perfect for zero-gravity meals. Sarah Walker, SpaceX Director of Dragon Mission Management, highlighted the innovative design of the boost kit. Because the Draco thrusters on the capsule aren't optimally oriented for a boost maneuver, we had to design a new boost kit that would fit inside the unpressurized trunk. This includes 6 propellant tanks, 1 pressurant tank, 2 Draco engines, and a new heater and insulation system to manage thermal challenges, she explained. The boost kit will provide Dragon with about 1.5 times the reboost capability of a Russian Progress spacecraft. While Progress typically performs 1 or 2 reboost burns, Dragon C211 will handle the majority of the orbit-raising maneuvers during its stay at the station. In addition to the critical supplies, the Dragon will carry 985 pounds of scientific equipment. This includes a European Space Agency ESA metal 3D printing experiment, a biotechnology study on lab-grown liver tissues with blood vessels, and a 3D printed medical implant experiment capable of delivering drugs or treating health conditions like nerve injuries. Heidi Paris, the Associate Program Scientist for NASA's ISS Program Research Office, emphasized the importance of these experiments. The SpaceX 33 Cargo Dragon spacecraft will be carrying hardware and samples to support nearly 50 different scientific studies and research facilities, she said. This mission is not only crucial for maintaining the ISS, but also serves as a stepping stone for developing the U.S. Deorbit Vehicle, an extension of the Dragon architecture, designed to help the U.S. and Russia perform a controlled deorbit of the ISS around 2030 or 2031. And this is the part most people miss. The success of this mission will pave the way for future space endeavors, ensuring that the ISS remains a vital platform for scientific discovery and international cooperation. What do you think about this new approach to maintaining the ISS? Share your thoughts in the comments below.